All right, what's up, everybody? So I know you guys are having a little bit of a hard time with representing linear inequalities. So I actually got to come back to my classroom for a quick moment here, so I'm going to do a quick video for you guys. All right, so I got two example problems I'm going to do for y'all. I'm going to start with the easy one over here. So we know that y equals mx plus b slope-intercept form, right? We're going to use this same type of thinking that we did all last week to move on into inequalities and graphing them like we did with our slope-intercept form, okay? So we know that this formula over here is the same thing we need to do with this information here. This is a little harder to do. This one's a lot easier to do. So I'll tell you what, we'll start with the easy one. So I know to get this to look like this, really the easiest thing I can do, and really the only thing I can do, is take my positive 2x, subtract 2x on both sides. I am now left with y by itself on the same side of the equation that I need it to be. My inequality doesn't change. I didn't divide or multiply by a negative number, so no need to flip my inequality. Now, I have negative 2x plus 3, and that's ready to graph. So again, my y-intercept tells me that I'm going to go up 3, right there. That's my starting point. Now, my slope is negative 2, so I'm going to go down 2 over 1, down 2 over 1, and again, I can see my line is literally moving that direction. So from my first starting point, my y-intercept, I can go up 2 over 1. And again, if you do this on graph paper, it should be a little bit more neat than what mine is. Now, I'm going to do a solid line because of that equal sign right there, the less than or equal. So again, that's a horrible line. Come on, Mr. Jones, you're better than that. That's not much better. But again, if you guys have a straight edge, right, you can do much better than that. Again, if that was not equal to, then we would break up our line, right? It would be a dotted, dashed line. But again, we know that that's there. So we want our line to be solid and filled in, hitting all of our points, and going on and on continually. Now we have to shade still. So if y is less than or equal to all of this information, right, less than, I like to go to my y-intercept. I know 2 is less than 3. I know that 1 is less than 3. I know that all this info should be less than all of that, right? And again, we can check that, and I'm going to show you how to do this in a second. But while we're graphing and setting everything up, let's do the hard one, okay? So let's see. Looks like we have a lot of things we need to do to get to that y equals mx plus b, our slope-intercept form. Well, let's see. First thing I know I want to do is I want to get my y-intercept over here. That'll cross that out. I still have my negative 1/3 x is greater than. Now I have my slope is over here. Excuse me, my y-intercept is over here, and I still have my negative y. Now I want to add my y to both sides. So now I have negative 1/3 x plus y greater than negative 4. And the last thing I have left to do is add my 1/3 x, add my 1/3 x. That cancels that. I have y now by itself on the side of the equal sign that I want. In this case, it's an inequality, but we can treat it the same as we would an equal sign. And again, I have positive 1/3 x minus 4. And again, now we can graph that, right? This is what we want to graph. So again, our y-intercept is all the way down here at negative 4. Our slope tells us we need to go positive 1/3, which would be up 1 over 3, up 1 over, and again, let's just kind of add on to our number line, up 1 over 1, 2, 3, and again now, and again we could just go down from our y-intercept, down 1 over 3, and it'll still be a part of our line. We don't have an equal sign. We're not greater than or equal to, so we need a dotted, dashed line to indicate that information. And again, if you have a straight edge, you can do this a lot neater than I am doing it. We still got a shade. So let's see, y is greater than, and again, we never had to flip our inequality because we never multiplied or divided by a negative number. But if we had to do that, which you very well could have to do that, make sure you flip the inequality. But again, we didn't do any multiplying or dividing by negative numbers. Our inequality stays the same. It's greater than all this, and I know -3, -2, -1, and so on, I know are greater than, so I am going to shade all this information up there. All that stuff on the graph is all going to be shaded. Now, let's pick a couple points. How are we doing on time? We're doing all right. So let's pick a couple points in each one of these to go ahead and figure out what we're going to do for checking our work. So let's see, I don't know, how about let's just do an easy one. Let's go -1, 1. So we're going to go -1, 1. That's going to be our checkpoint. So we're going to plug it back in to our original number, or excuse me, inequality equation. So we're going to go 2 multiplied by -1 plus 1 should theoretically be less than or equal to 3. Let's see. 2 multiplied by -1 is -2 plus 1 is going to be -1. Is -1 less than or equal to 3? I think it is. Check.